All right, let's talk about one of the most important, but honestly, least glamorous parts of building AI that actually works: chunking. It might not be the flashy part of AI, but I promise you, it is the absolute secret to getting accurate, reliable answers from your RAG systems. So, does this sound familiar? You've built a RAG system. You pick the best LLM, the fastest vector database, the shiniest new embedding model, and it still gives you garbage answers. If you've ever asked yourself this question, I'm willing to bet the problem isn't where you think it is. This right here, this is the fundamental truth. You can have the most powerful model on the planet, but the quality of your AI's answers is built on a foundation. And that foundation, it's all about how you prepare your data. Okay, so here's the game plan. We'll start with why chunking is RAG's unsung hero. Then we'll look at the default method everyone uses and the upgrade you should be using. After that, we'll get into splitting by meaning and even cover some advanced pro-level patterns. We'll wrap up with some practical advice and a clear action plan so you can build a solid foundation for accuracy. So let's get right to it. Everybody is obsessed with the models, right? But we really need to be talking about the data prep, because this one step, chunking, is where most RAG systems either fly or completely fall apart. So what even is chunking? Well, it's pretty simple, really. It's just the process of breaking down big documents into smaller, more manageable pieces, or chunks. We have to do this, right? You can't just shove a 50-page PDF into an LLM's context window. These little chunks are what get turned into embeddings and stored in your database so the AI can find them later. And this creates what I like to call the Goldilocks problem. If your chunks are too big, they're packed with noise and irrelevant stuff that just confuses the LLM. But if they're too small, they don't have enough context to make sense. Both roads lead to bad answers. You need your chunks to be just right. So here it is. This is the brutal, simple truth. Bad chunking leads directly to bad retrieval. And if you retrieve garbage from your database, even the most powerful LLM in the world can only give you garbage answers back. All right, let's build on that. We're going to look at the most common way people are chunking their documents today, and, more importantly, why it's probably the root of all your problems. So this is the default method you'll see everywhere, especially in frameworks like LangChain: fixed size chunking. It's exactly what it sounds like. You just take a document and chop it up every, say, 500 characters. It's simple, it's fast, and it's kind of dumb. And here's why it's a problem. This method is completely blind to what the text actually says. It has no idea about sentences or paragraphs. A chunk could literally start in the middle of a word. In a legal document, it might just slice a critical clause in half. Why? Because the boundaries are based on pure math, not meaning. So what's the upgrade? It's called recursive character chunking, and honestly, this should be your new default. It's a much, much smarter way to split your text, and there's a good reason it's what you see in most production RAG systems today. Instead of a blind chop, this thing works down a list of priorities. First, it tries to split your document by paragraphs. Makes sense, right? If any of those chunks are still too big, it'll then try to split them by sentences. And if a sentence is still too big, it'll go down to words. It does its absolute best to keep the natural structure of the language intact, which gives you way more coherent chunks. But hey, we can get even more intelligent than that. Recursive chunking is a fantastic baseline, but whatever chunking strategy could actually understand the content and structure of the document. This is where structure-aware chunking comes into play. The idea here is to use the document's own formatting, like markdown headers, HTML tags, or sections in a PDF, to decide where to split. I mean, a heading and the text that follows it, that's a natural logical unit. This method just makes sure they stick together. And that brings us to the most advanced approach, semantic chunking. Now, this method doesn't care about characters, it doesn't care about headers, it cares about ideas. It actually embeds every sentence and then measures how similar they are. When it finds a point where the topic suddenly shifts, it knows, aha, that's a perfect spot for a new chunk. And this really sums it up perfectly. Structure-aware follows the format of the document. Semantic chunking follows the flow of ideas inside it. Now, semantic chunking is definitely more expensive. It takes more compute power. But if you're dealing with documents where accuracy is absolutely critical, it's going to give you the highest quality chunks, hands down. Okay, so now that we've got the core strategies down, let's talk about a couple of pro-level patterns. These are the techniques used to build those top-tier production-grade systems that really work. So this brings us back to that core challenge we talked about. Small chunks are fantastic for finding an exact match to a user's question, but they often don't have enough context for the LLM to give a really good answer. Large chunks have all that juicy context, but they're noisy and less precise for searching. So how do you get the best of both worlds? The solution is this awesome pattern called small to big, sometimes called parent document retrieval. It's brilliant. You embed small, focused child chunks to get that high precision retrieval. When a user asks a question, you find those tiny, perfect chunks. But, and this is the magic trick, before you send anything to the LLM, you go and grab their larger parent chunks. You get the precise search and the rich context. It's a total game changer. Theory is great, but let's make this real. How does this actually look in practice? I'm going to give you some real numbers to start with, and then talk about a feature that's basically a hidden superpower for your RAG system. Look, choosing the right chunk size is just as important as the strategy. This table is a great starting point, kind of like a cheat sheet. For a general knowledge base, 300 to 500 tokens is a good sweet spot. For really dense legal docs, you might need to go bigger, maybe up to 800. And for short FAQs, you want tiny, focused chunks. But remember, these are just starting points. You've got to test and see what works for your specific data. Now for that superpower I mentioned, metadata. Seriously, no matter what chunking strategy you pick, you should always be adding metadata to your chunks. Things like the document name, the page number, the section it came from, this stuff is pure gold. And this is why it's so powerful. With metadata, you can filter your search before the vector search even kicks off. You can tell your system, hey, only search in documents from the last 3 months, or only look in the engineering handbook. It transforms a vague search into a laser-focused query, and that massively boosts your accuracy. Phew, we have covered a ton of ground, from why the default methods are kind of broken to some really advanced production-ready patterns. So let's put this all together into a clear, simple plan. Here is your playbook. Step 1, start with recursive character chunking as your baseline. It's a solid, smart default. Step 2, measure. You have to know if you're getting better, so build a small test set. Step 3, experiment with the advanced stuff like semantic chunking or the small to big pattern, especially for your most important documents. And finally, step 4, always, always, always add metadata. This one's non-negotiable. So I'll just leave you with this one final thought. The next time your RAG system gives you a weird answer, resist that first instinct to blame the LLM or swap out the model. Instead, ask yourself, is the problem with the AI's brain, or is it the information we fed it? I guarantee you, more often than not, the answer's right there, in the chunks.